Hello, everyone. So today we're going to start working with functions. And functions are a really important part of computer science and programming, and you will be using them throughout your CS career. So it's really important that you spend time getting to learn them and working with them correctly. So what is a function? Well, a function is just a group of statements, that have been put together that perform a specific task. Now, we have void functions and value returning functions. And both of these types of functions, void and value returning, can have arguments or no arguments. So, um, throughout the semester when you're working with functions, it's very important that you learn the difference between void and value returning, as well as obviously knowing that both of those types can have arguments or no arguments. Today we're going to focus on void functions, and we're going to look at void functions with and without arguments. So generally, what we've been doing up until now is doing, a whole bunch of statements. We have some, if statements, some loops, but it's just a whole, like a block of code. So what we're going to start doing now with functions is dividing this code up into smaller tasks. And each of these smaller tasks can be performed by different functions. And that has some of these benefits. So by dividing the program into these smaller parts, first of all, it makes it simpler to understand. That's really obvious comparing these two. It eliminates redundancy. So this means that you write some code once and then it can be reused wherever else you want, rather than having to rewrite it many times. It's also helpful if you need to change something, you just change it in one place rather than you have to change it in all these myriad different places where you've written that piece of code. It's really great for teams. So there's actually 2 points for that. So I know in your undergrad, you are not allowed to look at other people's code and things like that. But in the real world, you're going to be working in teams and you're going to have to be understanding other people's code, and other people are going to have to understand your code. And we'll come in a few slides to another concept, but it's really helpful for you to be able to use functions that other people in the team have written, and for other people to use the functions that you have written. So common functions, but also it means that you can focus on just one piece of the program and other people can focus on another. And we'll also look at this as well. It's easier to test, so you can just test one function so at a time. So if you have a bug, you can comment out the other functions and just go, oh, okay, I've isolated the bug to this function, so something is not working with this small part. Okay. Now, we have already been using functions. We've actually been using built-in functions from Python. So as you know, things like type, print, converting to an int or a float, input, all of these things are built-in functions that someone has written in Python, and we're just using them and calling them. So we're actually going to start defining our own functions. So I guess I'm going to put this slide up here. So when you get it, this slide will come first. So before we look at defining your own functions, this concept I actually want to introduce. So there's this thing called procedural abstraction. So a procedure can be considered like another term for a function. So you can have something called procedural abstraction. So the idea behind this is that we know what a function does, but we don't know how it does it. So the idea is, like, for example, if you're working on large complex pieces of code with many people, and or even your own code that you wrote just a few months ago, and you're focusing, say, on one task, and someone else is focusing on another task, you don't need to know every single detail about how they've written every single function. But if you need to, you might need to call one of the functions that they've written, and vice versa. If you've written some functions, someone else could call one of your functions without having to know everything you've done to write it, which is exactly what's been happening with these kinds of functions. You know, you don't know how someone has written print so that something will print on your terminal, but you know what it does, you know. So that is an example of procedural abstraction, and that's a, you know, a term that you'll come across later as you go along. So I just wanted to introduce it here as well. Okay. So anyway, predefined functions. So we've been using them. Now you're going to start writing your own. So let's have a look at defining your own functions. Well, you always start with the def keyword that starts for definition. And then you have your function name. And then you can have some arguments if you wish, or no arguments. So you have some parentheses and then a colon and then an indentation with whatever you want to happen inside of your function. We're not going to be looking at returns. We're going to look at value returning functions next lesson. And we'll look at arguments or parameters a little bit later in this talk. All right. Okay. Okay. So void functions, which we'll be focusing on today, do not return any values, but they can still print something. So here is the format of a void function with no arguments. So you can see there's nothing in there. It's just parentheses and colon and indentation. So here is an example of you have to define the function and then you have to call the function. Now, this is really important. It's not enough to just define the function. You have to also call it. So far, you know, when you've been doing something like print or, you know, type, you've been calling functions. So now we're going to learn how to define them and then call them. So here is a really simple example. We can start with this. So if you want to go to Sublime and create a new tab, you save it in week 5. I call mine func.py. So here is the function definition, example void function. It's a really long name, sorry about that. But that's the function name, parenthesis, colon, indentation, print. Here is an example of a void function. And then we're going to call the function by just calling the function name and parenthesis. So let's go ahead and run that. Let me move this down. Okay. And here it is. You just get the printout. Here is the example of a void function. I need to call it. If I don't call it, nothing will happen, even if I define the function. So please know the difference, and I'll be asking you about the function definition and calling the function. So this is def for definition. We define what we want the function to do. And then here, this is, you know, we want to call the function and wherever we want to put it. So let's have a look at a longer example. So, you know, say you had this piece of code and we wanted to display a store menu, and we had something, you know, like while user choice is not equal to 4, you know, print this menu. And then looking at the user choice, we say if it's equal to 1, do this, if it's equal to 2, etc., etc. So what if we could break this up a little bit and put these lines of code into a function like this? What if we could define a function show menu get choice, and then we put these lines in there. Then what we could do is we could go through the code, and when it gets to that point where we need to display all the lines, we call that function. So the program counter would start here. It would go to this line, then the next line, then this line. It would check if this is true. And if it is, it would go in here. It would come to this function call. So then it would go to where the function definition is and go through all of these lines. And then it would come back to where the function was called, and then it would continue on. So it's just like these lines are in there, except we've broken it up and put all the menu items under that function definition. Okay. Now I'd like to introduce a topic called main. So there is something called the main function, and it calls all the other functions in the program as they are needed. And you could say like the main function contains the overall logic of your program, and it's where we start in a program. Now, it's a little bit different in Python. Like if you've programmed in Java or something like that, you have a main and you always start in your main. In Python, you don't have to have a main. Like you can, like here we don't have a main, we're just running some functions, or any code. But a lot of the times with a lot of programming languages, you need a main. So we want to get you into the habit of using a main function. So that's why we have to, that's why we're going to introduce it here like this. So what we're going to do a lot of the times is have you define a main just like any other function. So you say def main, no arguments, colon. And inside your main is like where you start calling your code. So you can run your different functions. You know, you could have, this is where you ask for input. You know, this is where we want to have the main part of your logic. So here is the example we had before with the function definition example void function. Except this time, rather than being just called, you know, like here, it's going to get called in the main. And then the thing is, we have to always run the main to start everything. So this will be the first call. So a lot of times people forget to do that. But let's have a look, an example. So I'm going to comment this out. And let's look at this. So here I have my function definition main, where I've called example void function, which I defined here, and then I run my main. So let's run this, and you can see here is an example of a void function called in a main. Good. So here is a few function definitions called in a main. So let's have a look at this one. You can call this something else or put it underneath. So here I have 3 functions, message 1, message 2, message 3. And then I've called my main, sorry, I've defined my main, and then I've called each of these functions inside of my main. And then I finally called my main here. So this is how I would like your code to be when we start working with functions. Neat and tidy. Each function has its own specific job. And then we call them, you know, in the correct order from the main. And, you know, here we might have if statements or while statements. This is a very simple example. And then we call the main. So we don't want spaghetti code. We want nice, neat, orderly code. And also, if you find yourself ever calling main inside of a function, you know something has gone wrong. Main always needs to be called by itself. It's where everything starts. So we start with main and we go through. So for example, here we'd call message 1. So that would jump here and we'd print this is message 1. We'd come back to message 2. We'd call that. That would print this is message 2. And then it would come back and then it would call message 3 and it would print this is message 3 and then it would stop. So let's run that. So you can see that here. This is message 1, 2, and 3. Right? So I think, oh, and so for example, we were saying like if you wanted to test something and you're like, oh, I think there's something wrong with one of my functions, like you could comment out message to, these function calls and just run this function call, message 1, and then it would just print this is message 1. And then you can say, okay, is there something wrong going on, and so forth. So this provides you with this nice orderly way of testing things and writing things out so that you have really nice, easy to understand code. So that is really what I would like you to aim towards. Okay. I actually just have to open the window, so I'm going to pause for a moment. Okay. So that was about our main and our functions. Now, because you're learning about functions, it's also important that you understand local and global variables. So this is a new concept that you haven't come across before. So it's important that we get this right. And it's something that students sometimes get confused about. So we're going to go through it step by step, make sure that it's clear, hopefully. So when we talk about the scope of a variable, it means that the scope is defined or exists, the scope exists everywhere it is defined. And so, for example, let's focus on local variables first. If a variable is created inside of a function, that means that its scope is just inside that function. So I'll repeat that. If a variable is defined inside of a function, that means that its scope is just inside that function. Now, for a global variable, if the variable is defined outside of any function, then it is a global variable, and its scope includes all functions that declare the global variable. So let's have a look, because that's all very well and good, but let's actually have a look at what this means. So we have an example here. Let's focus on local variables first. So here is a function getName, and it defines a function name. The name equals input, enter your name. Because name is defined inside of a function, this is its scope, the function, and it's a local variable. Let's actually copy this code into a new file. I called it local var. So here's the function getName. Here is this local variable name. Here is the main. The main is calling getName, and then it's printing hello, and then the name variable. So let's see what happens when we try to run this. So I'm going to enter Ada, and look at what happens. It says name is not defined. It can't find this variable name. So what is happening there? So because name is a local variable, it only exists inside this function. It cannot exist outside. So when we finished calling getName and we went to print hello name, this name disappeared from memory. So I would like to show you what happens using Python Tutor Visualize. So if you could please open up Python Tutor Visualize and copy and paste this code in here. And then we're going to do visualize execution. And it's fine, we just keep the comments in there. And then let's go. So we're going to start with the main. Okay, so that's the first thing. So the main is going to call the main function definition. That's going to call getName, which is going to go up here. So this is the program counter, and it's going to say, okay, name equals enter your name. So let's say Ada. So you see here, this block, this is the getName function here. And you see here, it's got the local variable name, and it's Ada, which is what I entered. The return value is none because this is a void function. We're not doing value returning functions today. So there's Ada, right? So we're inside this function. Now watch what happens when we leave the function and we go back to the main. It disappears. It is no longer existing. So that's why when we try to call this line, it says name is not defined. Right? Because see, it's not there anymore. It's not there. Okay. So think about that, try that. Let me know if you have questions. So now what I could do here is, let's see, I could say, for example, name equals Bob, right? Let's see what happens if I do this. I'm going to say name equals Bob. So this is now a global variable in the sense that it is defined outside of a function. So now it should have scope in all of these functions. Okay. I'm going to enter Ada. Hello, Bob. Right? Now it's saying hello, Bob. So what is happening? Well, let's have a look. Let's copy this, go back to Python Tutor Visualize, put this code in there, and let's run. Oh, it's so funny. It's saying, you just fixed this error from the last time. Okay, that's fine. Let's close that. So let's go. Name, this is global frame, so it's global variable Bob. So then we go through our functions and we start with main. Get name gets called, we go in there, and then it asks for input. I'm going to say Ada. Now look at this. There are two name variables. Here is the local name variable inside of getName. This is in memory, right? And here is the global name variable Bob. Okay, so I'm still inside this variable. I'm going to keep going, get back to my main, and you see that this local name has disappeared when I left. And so when it goes to print hello name, the only name we have here is Bob. So it's going to go there. Okay. So that's important. And then let's have a look at an example of a global variable using the global keyword so we can do something slightly different. So we can copy this code and put it under global var. So here we have, instead of names, we have integers. So we have a global variable number, which is 0. And then inside our main, we have a global number. So we're making the variable number global inside of the main. So we're saying when we refer to number inside of main, we don't want to refer to a local variable. We want to refer to this global variable. So that's what this global keyword is doing. Then we say, okay, we want to change it. So we enter, some integer, and then we call show number, and show number prints number. Okay, so let's run this. So I'm going to enter a number obviously different from 0, so 2. So it says the number you entered is 2. So you can see there that it's retained the number that I entered instead of using 0. So let's copy this and put this into Python Tutor Visualize and see the execution. So here's our global variable, number equals 0. We start with our main. So we're saying number is going to be global. So we're going to use this one, not create a local one. And then we ask for input, and I'm going to enter 2. And then you see here where number was 0, now it's 2. We've changed the global one. And so instead of creating a local variable, we've changed the global one. Then we go to show number. And then when we go to print under show number, it's going to print 2 to what we changed it. Okay. Now, what would have happened if we'd commented out this global keyword? So just think for a moment. If I enter 2, is it going to print 2 or is it going to print 0? So let's have a look. I enter 2. Now it prints 0. Okay. So let's see why this is happening. So if we go back, and here I'm just going to comment this out, and we go back. So now we say, great, number is 0. And then we start in our main. We're no longer declaring number as global. So when we ask for input 2, you see now a local variable 2 is created. Instead of changing the global, a new variable local, sorry, new local variable number has been created. So when we exit the main to go to show number to try to print number here, it is referring to this global one, right? So it's not recognizing, because this number only exists inside of the main. So if we keep going back to the main and then we exit out of the main, you'll see that that local number has disappeared and the only one remaining is the global. So this takes a little bit of time to think through and understand. So please go through this, make sure you understand, try different things, try changing things. Don't be afraid to play around and try to break things. So global and local variables, very important. Please talk to me and ask questions if you have any questions about that. Okay. All right. Now, final thing for this lecture, we're going to look at functions that take arguments. So obviously today we're going to focus on void functions that take arguments, and then next lesson we'll look at value returning functions that take arguments. So some functions take in arguments. So an argument is information that is needed for the function to run. Like, for example, we were saying, if you want to print something, you have to tell it what you want it to print. So it'll say, if you say print, it's going to say print what? So we have to tell it give it some information to run. If we want to convert something to an int, it's going to, what do you want me to convert to an int? So we can define and call functions that take arguments. So here is an example. Here is a function that says double number, and it takes an integer num, and then it creates a local variable result and multiplies it by 2 and then prints it. And then when we call it, and this is the thing that students, I think, takes a moment for them to get. When you call it, they're saying, well, what is the value of this? Where do you get this from? you get it from this. So when you call the function, you're passing in the value that you want this num to have. So we're going to have a look at that, but I want you to put it into a main. So here is the function definition with an argument, and here is the main. So let's actually do this in Sublime, it's way better. Like this. So here is the function definition, and here is the main where we're calling the function with specific arguments. Okay, so let's run this. What's it called? Arg. All right, so here what we've done is we've called the first one with the value 4, so it's given us 8, and the second one we've called with the value 10. Let's copy this and put this into Python Tutor Visualize and see how this works. Okay, so if we go, so we're at our main, and we're going to call double number with the value 4. So there's, as we enter the function definition, you can see that num has been given the value 4 because of this. So when we go there, num has been given the value 4, so we're going to say result equals 2 times 4, there's 8, and then we're going to print result. And because result is a local variable, when we exit out, this will all disappear. And then we'll do the second one, double number, and it will call it again. Now number is the value 10. Or by the way, the 8 is printed there. The second time you can see here, num has the value 10. Local variable is created again. This time it's got 20, and then we print the local variable there. We exit, all of this is gone. We exit the main, and we're done. And there's your 8 and 20. So that's an example of using arguments. We can also use multiple arguments. So you could say like add num1, num2, and then total equals num1 plus num2. But then you'd have to pass in 2 like that. And you can see here that you can add those into a main.